All right, guys, I want to work a couple of projectile substitution problems for you. The first one is a lot like the one we worked out in the book a day or two ago. A daredevil jumps a canyon 24 meters wide. To do so, he drives a car up a ramp that's at a 20-degree angle above the ground. If his landing height is the same as his takeoff height, what is the minimum speed he must achieve to clear the canyon? Just like any of these projectile problems, the first thing that you've got to do is keep your horizontal and vertical components separate. So let's go to another slide and see what we can do in terms of working this problem out. We've got to remember that the canyon is 24 meters wide and that he's jumping at an angle of 20 degrees above the ground. So let's first of all draw out the velocity. So he's at an angle of 20 degrees. First thing I'm going to do is draw down and make some components. And I'm going to call this my up component, and this is my H component, horizontal. And I'm going to solve for those components. So I'm going to say the sine of 20 equals my up component over my initial velocity. This is actually what I'm looking for in this problem, this speed. Cosine of 20 is going to equal H over V. So let's solve those out. My up component equals V sine 20, and my horizontal component equals V cosine 20. All right, the first thing I'm going to do is think about the horizontal stuff that's going on in this problem. Usually when we're trying to find a horizontal distance or displacement in a problem, we work with this equation, delta H equals VT. Well, that's the same one we're going to work with in this particular problem. We know that the distance that we need to cover is 24. So I'm going to plug that in. 24 equals the velocity that we need to work with, because remember, we're working horizontally right now. The velocity that we need to use is this one right here, the horizontal component of the initial velocity. So I'm going to say V cosine 20 times T. That's about as far as we can go horizontally right now. Save that thought. Now let's flip over. Actually, we might be able to work it here. Let's try it right here. Now let's think vertically. Vertically, typically the equation that we're going to deal with when we work this kind of problem is the delta H or delta X, or usually probably delta Y might be better to put here since we're talking vertically. But I'm going to say delta X equals VIT plus 1/2 AT squared. Now the problem specifically tells us that the height he leaves the ramp from, is the same as the height he lands on the other side at. So our vertical displacement is 0. Our VI here is going to be the initial vertical velocity, which is going to be this, V sine 20. So I'm going to say V sine 20 times T plus 1/2 AT squared. Well, my acceleration vertically is gravity. So this 1/2 A is essentially 1/2 times negative 9.8. So I'm going to write it this way, negative 4.9 T squared. Key thing to notice is in both of these equations we have two variables. So we're going to have to solve one of the equations for a variable and then do some substitution. And the easiest way to do that would be to go up to this top equation, the horizontal equation, and solve for T. And you should be able to see that T equals 24 over V cosine 20. Just solve this equation for T by doing a little bit of algebra. Now I'm going to take this T and I'm going to substitute it for T here and for T here. So let's do that down at the bottom. So what I have is 0 equals VI sine 20. And now I've got to substitute T. So times 24. And that's, since I'm multiplying, everything's going to be over V cosine 20. Now notice these V's are both the initial velocities. They're both going to cancel out. We don't have to worry about those V's. Let's keep going though. Plus negative 4.9 T squared. So we can substitute 24 over V cosine 20 in there. We got to square all this. All right, I think before I do anything else, I'm going to move the negative 4.9 over to the other side. Let me make a little space. So again, I'm going to take this term and I'm going to add it to the other side so it's not negative. So I'm going to have 4.9 times 24 over b cosine 20, all that squared. And that's going to equal sine 20 times 24 all over cosine of 20. All right, I think the next thing I'll do is go ahead and simplify all of this stuff, because I can do the math on all that real quick. So let me get a calculator and go the sine of 20 times 24, all divided by the cosine of 20. Let me check the work on that real quick. So that comes out to be 8.735, all of this. All right, let's go ahead and come over to the other side, and let's substitute. Let's go do some math here. I'm going to go ahead and square 24. So 24 squared. That becomes 576. I'm going to square the v, and I'm going to square the cosine 20. Now I can get rid of this square term out here in these brackets. I'll go ahead and multiply 576 by 4.9. So now I'm going to have up top, I'm going to have 2,822.4 all over v squared cosine 20 squared. And that's all equal to 8.735. To get that v squared off the bottom so I can solve for it, I'm going to multiply both sides by v squared. So it'll cancel over here. And I'll have v squared over on this side. Now I've got to divide by 8.735. So I'll do that on both sides. And now this is very workable. So let's go 2822.4. I'm going to divide by 8.735. And then I've got to divide by the cosine of 20 squared. And I'm just going to divide by the cosine of 20 2 times to make that work. So divided by 20 cosine divided by 20 cosine. Right, when I do that, I get 365.9 something. But that's equal to the square of v. So I need to take the square root of 365.9 something. And what I end up with is my velocity equals 19.1 meters per second. That's the minimum velocity the guy can leave the ramp at and still make it to the other side. Now, one more substitution problem I want to work for you. And it looks like this. Again, much like when we worked in class today. A basketball player shoots a ball from a height of 2.5 meters above the ground. He wants the ball, that should say to go straight through the center of the rim, no backboard. If the basket is 3.05 meters high and 12 meters away horizontally, at what initial speed must he shoot the ball if he shoots it at a 50-degree angle above the horizontal? So again, we need to make note of some things. He shoots it from 2.5 meters above the ground. The basket is 3.05 meters high. It's 12 meters away. And he's shooting it at a foot angle, 50-degree angle above the ground. Those are the important pieces of information. So let's go to the next slide and let's think. First of all, we're going to draw out our vector. We're looking for this velocity. We know the angle here is 50 degrees. So just like always in a projectile problem, we're going to draw down a vertical, up, and horizontal. And let's solve for those components. So I'll say the sine of 50 equals u over v, which means u equals v sine 50. And let's say the cosine of 50 equals h over v, which means h equals v cosine 50. And just like always, we want to keep our horizontal and our vertical stuff separate. So let's start horizontally. When we're dealing with horizontal projectile problems, we're usually going to use delta x equals v t, because we know that the horizontal component of velocity is constant. In this particular problem, we know delta x, it's 12. We want the ball to go 12 meters from side to side. The velocity is the horizontal component of the initial velocity, which is going to be v cosine 50. And then we've got the time. That's about as far as we can go right now. We don't know v, we don't know t. So now we need to think vertically. Vertically, we usually use the equation delta x or delta y equals vit plus 1/2 at squared. We might also write this though, final position minus initial position. That's a change in position or displacement equals vit plus 1/2 at squared. Because in this problem, we know our final position. We want the ball to end up there at the rim, which is 3.05 meters. The ball started at 2.5 meters. So that's our change in position, our displacement. The VI is the initial vertical component of the velocity, so that's v sine 50 times t plus 1/2 at squared. Now the acceleration vertically is negative 9.8, so we're just going to write this minus 1/2 times that, minus 4.9 t squared. Let's go ahead and simplify a little bit. Let's take the 3.05 minus 2.50, 0.55. So we've got 0.55 equals v sine 50t minus 4.9 t squared. Now this might be a little easier to work with. Well, actually, we can leave it this way. Now we need to do some substituting. And what we're going to have to do is solve one of the equations for a variable, substitute it in the other. And the easiest way to do that is to take this top equation, the horizontal equation, solve it for t. So you should be able to see that t equals 12 over v cosine 50. We're going to take this and substitute it in for t here and for t there. So let's see what we get. We're going to need to make some space. We'll do a little erasing. I'm going to go ahead and write down what t is equal to in terms of that horizontal equation. Because I'm going to erase this stuff up top. And I'm going to do my substituting up there. So again, my equation at this point is 0.55 equals v times the sine of 50 times t minus 4.9 t squared. Okay, so let's substitute. 0.55 equals V sine 50. Now let's substitute T. 12 over V cosine 50. And since I'm multiplying, that V cosine 50 can be written like this. Go ahead and notice that we've got V on top and V on the bottom, so those cancel out. Minus 4.9 T squared. Again, substitute 12 over V cosine 50. All that's squared. So let's go ahead and try to simplify some of the math. Let's take this term and go ahead and do the math. So let's go 50 sine times 12 divided by the cosine of 50. That comes up to be 14.30. Take all that out. We'll replace it with 14.30. Going to go ahead and do some squaring over here to simplify this. So let's square 12, get 144. Square the V. And then just write cosine 50 squared. That way we can get rid of these parentheses and that squared term right there. All right, we can go ahead and multiply 4.9 times 144. So when we do that multiplication step, that gives us 705.6 on top. Let's go ahead and divide 705.6 by the cosine of 50 squared. That comes up to be 1707.75. Now that's still all over V squared down here on the bottom. So here's what we've got so far. Now I think what I would do next is go ahead and subtract the 1430 from both sides. So let's go 0.55 minus 14.30. So that gives me negative 13.75 equals 1707.75 over V squared. And that's minus that. Since we've got negatives on both sides, those can be canceled out. Divide by -1. I need to multiply both sides by V squared to get that off the bottom of my fraction. And then finally, I need to divide by 13.75. So 1707.75 divided by 13.75. Cancel that out over here. And then since I've got V squared, I need to take the square root of both sides. And I end up with 11.1 meters per second. That's the velocity, the speed that the basketball player should shoot the ball at, assuming he's shooting it at a 50-degree angle and he wants it to go directly through the net. Hope that helps.